Hello, Matt Davis here with more homework quiz help. This one comes from section 8.3. Suppose a random sample of size 31 produced a mean of 87.44 with a standard deviation of 13.858. Determine a 90% confidence interval for the population mean. Enter only the left or lower endpoint of the interval below and round your answer to 2 decimal places. So let's first firmly establish where we are, what the setting is. So they want us to find a confidence interval. So we're looking for a confidence interval formula, and it's for a population mean. So we are in mean land. So confidence interval for a population mean. So the first thing I want to do is start off by writing the formula down for that. So we would want x bar plus or minus a t star times s over root n. So that's our formula sheet for a confidence interval for a population mean. Now let's make a couple changes here so that we're giving help and not answers. So instead of doing a 90% confidence interval, I'm going to go ahead and switch that up, and we're going to do 95. So all the work will be the same, but we'll get a different answer because of that switch. All right, so let's go ahead and start gathering the information. We need an x bar. So they told us the sample produced this mean. So that is a sample mean, and therefore that is x bar. And then they said that the sample produced this standard deviation, which means that standard deviation is a sample standard deviation, or S. So from our formula, we have x bar and S, so we need a sample size right here, 31, so that's our n. So the only piece that remains is the t star, and we get that t star from our confidence interval. So we'll start off by drawing a bell-shaped curve. We're going to put 95% of our area in the middle, but we need to do that in decimal form, so 0.95. That leaves 0.05 left over. We split that into 2 halves and put the 0.025 on each side. Whenever you're drawing this picture, always make sure you add these 3 numbers together and that your total is 1. Sometimes people forget to divide by 2, and that will make the total not be 1. Sometimes they put the decimal in the wrong spot. That'll make the total not be 1. And all of that will mess up our t-score. So just add those together, make sure you get 1, and then you're in good shape. And then this right boundary over here will be t star. So I'm going to find that using the t-table. I think that's the most efficient way to do it. And whether you're doing the t-table or using your calculator to find the t-score, you need to take the n they gave you of 31 and convert that to a df by subtracting 1 from it. So if n is 31, then our df will be 30. And so then the t star that we want is going to be equal to the t with the area in the right tail that's listed there, so t of 0.025. And we just want to go get that off of the t-table. So let's switch over to the t-table for a minute and have a look at that. So we want t of 0.025, so we want to be in the t of 0.025 column, so somewhere in here is where we're going to get our answer. And we calculated that our df was 30, so I just need to scroll down a little bit farther, get to this spot where we have the df 30 row, and where those two intersect is our t-score. So we're going to want to use 2.042 because that's from the row with a df of 30 and the t of 0.025 column. So that's going to get the job done. So again, 2.042 is what we need. So 2.042. So now we have all the pieces of the formula we need. This was all scratch work down here to gather that information. So now let's start plugging into the formula and see where that takes us. So the x bar, we had that highlighted up above as 87.44. We just found our t-score, that's 2.042. And then we're going to multiply that times s, which again they gave us up here, 13.858, and divide that by the square root of the sample size, which was 31. So we'll copy down our x bar again, 87.44, and then we're going to go to the calculator and we're going to work on this margin of error part right here and write that in right there. So let's go switch over the calculator and calculate that margin of error. So we want to start off with our t-score, 2.042. Multiply that by s, 13.858, and divide that by the square root of the sample size, which is 31. So there we go. We had on our x bar 2 decimal places, and you're supposed to match the margin of error piece with the decimal places on the margin of error piece with your point estimate. So point estimate was 87.44. So we want 2 decimal places on this one also, which would be 5.08. So switching back over, we want 5.08 for our margin of error. And then after that, we can go to our confidence interval for the population mean mu by first subtracting. So take the 87.44 and subtract 5.08, and we will get the left boundary, and that is 82.36. And then for the right boundary, we do the same thing, except for now we're doing the addition instead of the subtraction. When you do that one, you get 92.52. And there's your confidence interval, which is what they asked us for. Sorry, I put a fat decimal place there so it'll show up. And let's clean that up a little. So 92.52. Sorry about that messy first version. There we go. All right, so there's the completed confidence interval, which is what they asked us to find. However, they also said only enter the left or lower endpoint for our answer. So sometimes they ask us for the margin of error right there. Sometimes they ask us for the right or upper endpoint right there. This time they asked us for the lower or left endpoint right there. So what's going to go into that active learning answer box for this version of the question is that number right there, the 82.36. Just a few quick things to remind you of to watch out for. Make sure that you're totaling these up to get 1, to make sure you didn't forget to split the leftover area into 2 pieces, or to make sure you don't have the decimal in the wrong spot. Make sure you switch from sample size to DF before you go to the table. Make sure that since there's 2 decimals here, you put 2 decimals there. We need those to match up. Those are the kind of common places that this can go wrong for people. Hopefully whatever was giving you trouble, you've spotted now. And good luck to you as you head back to the quiz and give it another try.